computer. Great. So if you guys can see the big turtle, you can see my screen. That's the hope. Yeah, so I'm just going to move around some of my screens. As you can see here, the topic for today is Git and by extension, GitHub. So what we're trying to do here is learn how to use Git as a CLI tool for version control and learn how to use Git with GitHub, which is your home for your code that doesn't just live on your own computer. So before going any further, we might want to look at what Git is. So as you might have seen already, Git is, this command on your command line. If I write Git, that didn't do anything, but it did show that I have it installed and all the things it can do. And as you can probably tell from this, it's a pretty complex tool. So what is Git essentially? The reason why Git gets so much special treatment, it is just another command line tool, but it's a tool for version control. So let's say you've used like Microsoft Word in the past. Let's say you save the file, and then you make some changes and you save the file again, right? Well, when you do that, you overwrote the file. You don't have the previous version of the file anymore. And maybe you're working on a big project and you have this situation where you're like, oh, I want to make some changes, but I don't want to necessarily lose my old changes. I want to be able to rewind to those old changes if I need to. And then imagine that it's not just that you have like one path, but you say like, oh, well, I might take this paper in a different direction, so let me try that for a bit. And I want to take it in a different direction and be able to maintain those changes without necessarily overwriting the original version of the paper. And that would be like the Git idea of branching. And then you can go a level even further where you say, well, I'm not writing this paper by myself. I'm collaborating with people. And we don't necessarily live in the same time zone or the same area, but we still want to collaborate. And that's sort of the evolution of Git, where what Git is it is a version control tool. So, if something has version 1, version 2, Git is a tool to keep track of changing versions essentially, or having different versions of the same thing. But because of the need to collaborate across the internet, it ends up being a very complex tool that if you look at it deeply, it's literally the problem of time travel and the problem of there being multiple timelines and the timelines splitting and then having to merge the timelines. And if you've ever watched, The Terminator or Back to the Future, you know that that's very complex to think about, almost too complex to really fit in your linear-based time human head. So Git is almost unavoidably complex. And we say that just to let you know that we're really going to be building up to it in pieces. And what we're going to focus on today is really using Git as an individual by yourself, just to track your own work. First locally, which means using Git, and then remotely using GitHub. And it's worth pointing out the distinction here that Git and GitHub are not the same thing. Git is an open source tool that absolutely anyone can use for the sake of version control, whereas GitHub is a private company that is now owned by Microsoft, which just makes it really easy to back up your local Git repos somewhere, in the cloud, so it will always exist and you don't really need to think about, having some physical server somewhere and what happens if that server dies. But I feel like just to get a feel for this, first thing I want to do is look at GitHub. So here we have GitHub, and I just opened this random repo called Lodash, which is like a JavaScript utility library. It just gives you lots of useful functions. And let's just look at this page for a second. So the first tab we see is code. And that is where, it's going to represent our code. And this is all the code. And as you can see, it's a lot of files. In this case, they're all at the root that represent this project. And you can see here, it actually tells you for each one, when was the last time this specific file was updated. And we could actually see, okay, the last person to update this project was this guy, Jacob LCS. This was the commit message. This is what he said he did. If we click here, we could actually see the details of that commit. Then this here looks funny, but these letters and numbers represent the hash, basically the unique ID for that specific set of changes, when it happened, and then the total number of commits. So there's been 8,005 commits on this one project. If we click on that, we can actually see all of them. So we can see every commit that's ever happened, exactly what changes they made. And if we click here, we can actually see the specifics of the changes. So in green and red, it says they added some lines, they removed some lines. And this is very useful when you work with other people because you're going to be able to see what changes someone made. You'll do what's called a code review, where you can just look through the changes and say, oh, that seems reasonable, or what's that over there? And there's just there's a lot of concepts, and we recognize that it's a lot to look at. So hopefully we're just going to break it down into, like, the essentials first. But as you can see, there's a lot going on, and it's not just like there's 8,005 commits here, but that's on what they call the master branch, or what's now called the main branch. But if I click here, I'll see there's other branches. So that means that, like, they wanted to try out some feature, they wanted to do some thing, and they have this like separate branch. And then if we look here at pull requests, this is not a Git idea, but a GitHub only idea. But basically someone can make their own branch. They can start making changes. So we would call this like a feature branch. They're saying, hey, I'm going to add this feature to the app. It doesn't exist yet. They start working on that separately. It doesn't affect the main branch. And then when they're ready, they open a pull request. And we could see here, like, this is an open pull request. This is not part of the main project yet. This person, there's a little conversation here. If we look here, we can see, like, they actually broke it down into 2 commits, which is like 2 separate change sets. And then we could see the files they changed and what changed in those files. And so this is like how projects get built over time, in a way that makes it very granular in terms of being able to say, oh, like, I made some changes, I want to, merge them into the main branch, and I need permission to do that. Or, I'm going to try something, but I don't want to mess up, the main thing. Or, oh, it turns out we have a major bug that got in the main branch. We need to, like, roll that back. And so all of that is possible because of how Git, and by extension GitHub, work. And as you can see, there's just so much more, like this actions thing. We won't touch this in the course at all, but this is an entire course and a separate engineering discipline at this point called DevOps, which is basically, how do you make it so that every time someone pushes a change, you, like, automatically run tests, or you automatically update some, like, testing server so that the QA person can look at it, and just automating the process by which, things move forward in a business. Okay, so that is what, just a little bit of what, like, the final version of something looks like. But for today, we're mostly going to be working in here. And the first thing to start with is Git itself, because even if there wasn't a website like GitHub, it still might be useful to have some version control tool for understanding, or for, keeping track of some project. And up here, I have this page open called, this website called Excalidraw. So I try and use this sometimes when the thing we're working with is visual. And so we'll look through this, but basically this is just a way of helping us, like, visually understand what we're going to be doing in Git, and we'll take a look at it sometimes. Okay, so the first thing we might want to do is to create a Git repo. So first we just need some kind of file, and I see I'm in my home directory. I'll just make it right here. I'll make a new file called my first repo, and then I'm going to go in there. And as always, I like to clear just because I want to be able to see it on the screen. So you'll notice sometimes it shows some, like, Git info, but it's not showing it right now. And if I say Git status, it's going to say not a Git repository, which is true. And then this .git is, kind of interesting. We'll see that in a second. So I said this is my first repo, but really I'm just in a folder on my file system right now. What is a repo? A repo just means a folder that Git is keeping track of. So how do you upgrade a regular folder to a Git repo? Well, the first thing I want to show you, if I type ls-a, remember -a is going to show me the hidden files. This is all I see, dot and dot dot, which means, a shortcut to look at the current folder or to look at the parent folder, but that's all that's in here. And now the first thing I'm going to do is type git init. So git, if I just type git, for example, you'll see it has all these different subcommands, and it takes a long time to learn all these. Virtually no one learns all of them. I don't know if this is a positive or a negative thing to say, but whenever git comes up, it always reminds me of this one friend of mine from college who he was earning like a crazy amount of money. And I'm like, what do you do day to day? And he's like, I literally just fix Git merges. I fix Git conflicts. And like, that sounds like a terrible full-time job to me. But like, if you can do that, that is such an in-demand skill that could be your whole job. I'm pretty sure he does more than that at this point. But as you can see, there's like lots and lots of these subcommands on Git. And I don't even see it here. Oh, where did I sorry, okay, there we go. I don't even see it here, but git init is, oh, there it is. So one of the most basic ones you can have, you've seen clone. Clone is how you clone an existing repository from GitHub. But let's say you were going to make a new one from scratch. You use git init. And I'm going to use that just to show you how you might do this on your own computer. Sorry, I keep moving things around and it jumps screens. Just Zoom stuff tends to get in my way when I'm trying to type. And I can't see what I'm actually looking at. Okay, so we're going to type git init and see what happens. All right, it says initialized empty Git repository in exactly where I am. And you'll see it says .git here. So first thing you might notice is that if you're using a fancy CLI, you'll actually see that it knows this is a Git repo now. And it's actually, this main here is telling you what branch you are on. So we're going to get more into branches later, but by default, you're on a branch, and that branch is called main. That's all you have to know about right now. We're already on a branch. You're always on a branch, and that branch is called main. And now note that if I did what I do before and I type ls-a, there's now a new hidden file called .git or folder. And just like any other folder or file, it's just something on the computer. So I can actually go into this folder and look at it. And even though we never actually do this, and that's why it's hidden, you should understand this is all Git is. Git just has, it has a folder with files and folders in there, and that's how it's keeping track of the history, the version of your repository, and everything is in there. So for example, if I go back up a level, and if I were to say remove that folder .git, instantly it doesn't know about Git anymore. So if I said git status, it says, hey, this isn't a Git repository. So that's actually all Git is. Git is just that one file in, that one hidden folder that's in your, the folder that represents your code. Okay, so that's git init. I suppose we could stop before each of these. Before moving on, any questions about git init? The chat.
I have a quick question. So just generally speaking, using Git, like what's the advantage over just having like version folders that you create in the GUI and just copying the file over and editing a new version?
Can you repeat that question?
I guess I'm just looking for the advantage of using Git, in the command line as opposed to just doing it manually and creating a new folder and copying a version of the file over and just doing it that way, like what I do with my resumes, for example.
Exactly, yeah. So what you're saying is what most people arrive at initially, which is like if you're trying to do your own version control, yeah, you just make a copy and maybe at some point you start dating it. because that's like a good way to keep track of things. And Git is just sort of like the extreme end of that attitude, which is, let's say I might have the most complicated version of a resume ever, and I'm sharing it with thousands of people across the world, and there's all sorts of versions of it. How can we make it so there's like one interface by which we can say, we want to move forward, we want, or like I want the most recent version, or I want 10 versions ago, or I want that experimental version we were trying because I want to make a little change, and then I want to merge it into the main version. So it's basically a complex answer, or it's an attempt to answer the most complex version of that question, which is, how do I keep track of versions of my resume? And before moving on further, it's probably worth saying that Git is a complicated enough tool that even major programmers are sometimes like, that's more complicated than I need. So Facebook famously did not use Git for a very long time. They used this alternative called Subversion, because Mark Zuckerberg was like, hey, I'm a good programmer, but Git is more complex than I need. I'm just going to use this simpler tool called Subversion. But as the company grew, Git became necessary, and really Git is the standard now, but it is sometimes frustrating because it's the most powerful tool possible. And it's sort of like learning to drive a car on like, you know, some like race car that goes like 1,000 miles an hour. Like, it's a little too powerful for virtually everybody who uses it. There's technically things in there that it's like, you can just go deep for the rest of your life. I still feel like I am personally just scratched the surface of Git, and that's kind of nuts. Like, there's ideas in Git people talk about that I'm like, I don't know what that is. And that can be frustrating. But basically, to answer your question, it's just an extreme version, or an extreme answer to the general problem of version control. And I'm just looking at the chat right now. I love that when the concept of bugs came up, people mentioned Grace Hopper. Grace Hopper really is an OG. It's actually, I can kind of nerd out on this. Grace Hopper kind of did the most significant, or one of the most significant things in computer science, which is she said it was worth losing a few compute cycles for the sake of usability. Everything used to be ones and zeros, and she was the first one with this to come up with this idea called assembly. And assembly is just a level up from ones and zeros, where now you're representing a bunch of ones and zeros with a word like add, ADD. And believe it or not, at the time, that was very controversial because people said, why are we wasting compute cycles? Because, you know, using a computer is so expensive. Why are we wasting it converting ADD into a specific set of ones and zeros? We can just remember the ones and zeros. But Grace Hopper's approach definitely won out, because now you use these very complicated programming languages and you have no idea about the ones and zeros under the hood. But thank God, because if you had to know that, you'd never get anything done practically. So yeah, big fan of Grace Hopper. And it is true that the word bug comes from the fact that there was an issue with the computer and they couldn't figure it out, and the code seemed perfect. And it turned out there was a moth in the computer, and computers were so big back then that the moth literally got between a vacuum tube, which was the then version of a transistor. A transistor is like 8 nanometers now, but back then that was like, you know, 3 inches. And so a moth was actually able to block something. So the code was right, but the hardware wasn't working right because of a moth. So that is a fun throwback. I see some people saying, how can you make the command line look fancy? Yes, someone shared that. And I also see this this thing about whether your branch is main or master. It will differ. Main is considered the standard now. Basically, a few years ago, for the purposes of, I guess, like political correctness, people didn't like the name master, which, since, like, you know, Git was invented in the 90s, that was what the main branch was called. Now the main branch is called main. It doesn't really matter. It's just the first default branch, and you can rename it to anything you want, but, you know, just stick with the default for now. Okay, so we have this Git repo now, and I can look and see there's still nothing in this repo. And one thing I can do, which I'm going to do a lot, is I can write git status. So early on, you really should be typing git status between every other command because it tells you what's up with your repo. And the only way you really learn these core concepts in Git is by typing git status. So because we don't have much here, it's saying we're on branch main, which is true. We have no commits yet. We'll get into what those are, but essentially we have no changes yet. And it's saying there's nothing to commit, meaning not only have we not changed anything yet, we have nothing currently that's even in an untracked state, as in we don't know what that is yet, or Git doesn't know what that is yet. Okay, so that's what Git status is. And as you can see, it tells you about what branch you're on. It can tell you about the nature of the files it's looking at. Untracked means it doesn't even know what this file is yet. Tracked means it knows what it is, but it's not going to be added to the next commit. And then staged means that it will be added to the next commit. And we're going to get into that whole commit thing in a second because it is the core idea. Before moving on, maybe I'll show git log just to show, okay, that's what it says when you have no commits yet. Git log would tell us the history of our Git of this branch, but it's not going to tell us anything right now because we have none. Okay, so the next thing we're going to want to do is actually add some files. So I created this Git repo, but there's nothing in it. So let me just add some files to it. And the way I'm going to do that is like this. I can do it one at a time, but it also works if I do it multiple at a time. I'm going to make a text file. I'm going to make a Python file. And I'm going to make a JavaScript file. I'm going to open them in Visual Studio Code. And then I'm just going to edit each one of these files. So in the text file, I'll just write hello world, and I'll save it, and I'll close it. And in the Python file, I'll write print hello world, and I'll save it. No, okay, I'll save it and I'll close it. And then in the JavaScript one, console.log hello world, and I'll save it and I'll close it. And now if I type ls here, I'll see I have all of these files. And then you might have also noticed that because I'm on a sort of fancy command line, it has this $3. And what that is going to tell me is it means it has 3 files, but they're untracked. It doesn't know what to do with them. So let me type git status and see what it says. Okay, so now we see a fair amount more. We see on branch main, still no commits, but we have some untracked files. So we see here we have these 3 files that are in red because it's untracked, meaning Git just doesn't, you haven't registered these files with Git. So there is a distinction between your folder, your file system, and Git in that you could add files that maybe you don't want, to make part of the history. It's just a temporary thing, whatever it is, you can actually tell Git, or you have to be explicit with Git the first time that you actually want to care about a file. And it's also telling us that we can use git add and then the file name if we want to start tracking it. So up here, I have this little visual thing so we can start thinking about it. So it's like this. We're starting out, we just have untracked, and then I have this thing called stage, and I have commits. But for right now, everything's empty besides for untracked. And maybe I have, 3 files in untracked now. And one of those was .py, and one of those was .txt. So these are 3 untracked files. And I put some contents in them, but ultimately Git doesn't care what the contents are, whether that code actually runs, whether it's valid. It just tracks files. Okay. So we can now add them using git add. And I want to show you that the first thing you can do is, if I write git status, it actually tells me I could say git add and then the specific name of the file. So let me try that. Maybe the first thing I'll do, I'll say git add, and then I'll do example, and then you'll see it autocompletes for me, but example.txt, git add example.txt. Okay, and now it's saying +1, question mark 2, and it's in orange. So if I say git status, it's telling me something a little different, saying, okay, we have one change to be committed. I call that staging. As you see here, it says do this to unstage. And then we still have 2 untracked files. So by typing git add example.txt, all we did was move this here. That's all that changed. So basically, these are files that Git doesn't care about, and this is a file Git does care about. But in reality, generally, you want to add all your files. Eventually, you start having certain folders you want to completely ignore. Like when we start using JavaScript or Python, or when we start using JavaScript a lot, and we have a lot of what they call dependencies, like you're using programs other people wrote, like React, for example. You generally don't want to push those as part of your Git repo because it's just too much, and someone else can just pull it locally from their end. So then you start ignoring that one folder in particular. But for now, we're going to add everything. Dave, are you saying something? Because I see you talking. Dave, man, I just saw you talking, but you're on mute. So if that wasn't for me, that's okay. Was that
I'm
for me?
sorry, I was talking to my Alexa.
Oh, yeah, no problem. No problem. I was just curious, like, does he want my attention? Okay. So instead of adding each individual file, generally the most basic way you do this is you do git add dot. And now that I did git add dot, you'll see it says main +3. And if I say git status, now you'll see it's not talking about untracked things. Everything it cares about is tracked. But importantly, there is this way you could say, I want to untrack that. So let's say I added something I didn't want to. I could say git, and I'm just following what they say. Like, I don't remember this myself, but I'm saying git remove cache. Let's say I say example.txt. That's the one I don't want to track anymore. So I could do that. And now if I say git status, it says we're not tracking that one anymore. But note that when I did git remove, it removed it from Git's tracking system, but the file is still there. Whereas if in my own file system I said remove, that file doesn't exist anymore. Whereas git remove just means Git doesn't care about that file anymore. But I actually want to add all of them, so I'll do that. And what do we have now? We have all 3 of our, let me get those other 2. We have all 3 of our files in this, changes to be committed. In other words, they're staged for commit. And what a commit is like a specific unit of changes. So it's like, let's say you made a bunch of changes in your Word document. In the example of like, you name your Word document something, and then you're going to make some changes to your resume, and then you want to name it like version 2 or something, or version the current date, to not overwrite the original. Well, everything we just did now, untracked to stage, those represent individual changes. So it's like every single character you changed in your resume represents, something that you want to keep track of. But then a commit is going to represent a new name for the file. So that's saying this is a specific version I want to keep track of that, has all these changes in it. So this is the big idea, or probably the core idea in Git, which is a commit, which is like a unit of work in Git. So there's a couple of ways that I can work with this. So the first thing I would do, like I can see if I type git status, I have these 3 things ready for commit. And so one thing I can do is I can write git commit. And what happens if I write that? So I'm going to write git commit and hit enter. What happens? Okay, it says git commit, aborting commit due to empty commit message. So basically it opened up this file, and I could theoretically write a commit message here, and then it says all these changes and stuff. And if we didn't set it up for VS Code, it would have done this in Vim. But this tends to be like a more cumbersome way of doing it. And as you could see, like, even though it was supposed to wait for me to finish typing and then it would like save the commit, and only if it was empty would it abort it. It got confused. So I'm just going to close that, and I'll show you the way that we generally do it. And the way we generally do it is we write git commit, but then we give it a flag, which is -m for message. And then we write the message right there in line. And the message there is just because once you're collaborating with people, especially, it's good to say what sort of changes you made. So people tend to get lazy here and you don't want to write too much. So I'll often just write like changes. But that's bad practice. In this case, it's perfectly fine because we added stuff for the first time. I'll say, initial commit. And then when I hit enter, we see some stuff. So it says main. I mean, I don't know what all this is, but we have this new commit called initial commit. We'll see in a second that this alphanumeric represents like the unique ID for that commit if we ever wanted to roll back to that specific commit. And it's telling us we added 3 files, or rather 3 files changed, and we updated, there were insertions, and we create those files. The change that was made is that they were created. And if you remove something, or if you just modify something, or you change the name to something, each one of those is represented in a specific way. But now what I can do is I can write git status again. And it says on branch main, nothing to commit, working tree clean. So basically what it's saying is there's nothing, you haven't made any new changes. If I made some new changes, it would track them. But for right now, I haven't made any new changes. But if I say git log, git log is going to tell me my commit history. So as we'll see soon, we generally just use GitHub for this because this tends to be an ugly way to do it. But this tells me that I made this commit. This commit has this long ID, which you generally only need the first like 8 characters of, but it has a long unique ID. The commit was to the branch main. Head means what we're currently looking at. So we're currently looking at this commit. The author was Benjamin Cohen with this email. That's why when you first set things up, we ask you to like give it a name and an email because it wants that information to keep track of who you are. And then, the date, and then the specific message, initial commit. And then to get out of this, I just hit Q and I'm out of it. Okay. So that is an example of a commit. So the next thing we want to show is basically how you might rewind to a previous commit. But in order to do that, I need to make another commit. And remember, at this point, we haven't done anything with GitHub. This is all just a fancy way of keeping track of your own changes locally. And it really is overkill if you don't eventually push somewhere like GitHub, but still, it's worth seeing it in this local environment first. So I'm going to make some more changes and then, create a new commit. So maybe what I'll do is I'll open example.py. Hold on, why is it empty? Oh, because that was called example.py. Well, that's actually a really good point. That let's say I want to change the name of it, right? I'll move example.py to example.py because I had a typo. And you'll see that actually counts as a change according to Git. So I'll say git status, and it says, it actually doesn't quite understand it. It says you deleted this one and you added this one, but it's untracked. So maybe I'll say git add dot. And now when I say git status, it understands you renamed example.py to example.py. And that's enough of a change that it's actually, that I can create a new commit that way. But maybe just to see another one, I'll open example.js. And maybe in there, I say like for let x of 1, 2, 3. I'll just write a little program here. Let sum equal 0. Sum plus equals x. Console.log sum. And maybe we would test this out and we would say like node example.js. Sorry. Yep, it prints out 6, so that's what we expect. And again, if I do git status, it's saying, okay, we know about this one change, but that other change, you made a change. We see you made a change, but it's not staged for commit. So we'll say git add. Again, git add dot is usually what you want. Git status again. Okay, you modified one file, example.js, and you renamed another file. Okay, so now I want to commit this one, and I'll commit it, and I'll add a message, and that message will be, renamed typo added example.js functionality. Great. So again, you're not really expected to read all that, but now if I say git log, we can see a little bit more where it says, okay, this was the initial commit, but more recently we had this commit over here, and we can identify the commits by the message. And then you'll see it says head main. So it's implying that this commit right here is where we are. So it knows about the whole commit history, but we're currently looking at the most recent commit. That's what our repo represents. Okay. So any questions up until this point? Because we have covered a fair amount.
I have one, it's kind of maybe unrelated. Just when you moved the file inside of another file and it said deleted, does that have anything to do with the fact that like strings are immutable and it like renames the path of it, or no?
I don't think it has to do with the fact that strings are immutable in terms of the file name, because in terms of the file name, it's just that like you're talking about the part where it said like we renamed the file, right?
Right.
And your question is, can you clarify your question?
You said underneath it showed it as deleted.
Yeah.
So I was wondering why it thought it was deleted when it was just moved.
I think the reason it did that is because it's basically we changed the name of it, and because we changed the name of it, it said, but we didn't necessarily add the new file. It was like, oh, you had this file called example.py, and you seemingly deleted it. But that's all it knows. And then when you say, well, actually, there's a new file called example.js or .py, then it puts it all together and it says, oh, you deleted something called example.py, you added something called example.js, and I think it's able to like, somehow it knows that's really the same file. And then at that point it says, yeah, you renamed it. Yeah, that's all. That's what I imagine. Also, I'm just curious, who was asking that question? Because Zoom doesn't always show me the person. I think maybe if their screen isn't on, it doesn't show the person, but who was asking that question just now?
It's Chris Wade. I don't know why it's not showing.
Interesting. Is his screen on? Oh, there we go. Oh, that was you? Okay. For some reason, yeah, this is just Zoom. Zoom sometimes highlights the person talking, sometimes it doesn't, and then it's just like a ghost. I'm like, who's talking? Yeah, cool. But yeah, I think we'll do this final idea and then we'll take a break for a second. So what we've established so far is that, we can create a new Git repo. We have untracked files, then we stage them. And then once we stage them, we have this like commit. And if I could do git log, I might see like, okay, the commit for this one, the commit for this first one is like, these bunch of letters. And that's like its unique ID. And then we had a second one that looks like this, and the commit for this one is going to be this bunch of letters. And then head now points here. But internally it does know that if it were to go backwards, this is where it came from. So, right, let's say I said, oh, I just made some changes. Those were not the right changes. I want to go back, right? So this brings us to git checkout. And So right, we want to check out a previous commit. And if I say git log, I could get that long thing. And I don't think you generally don't need the whole thing. You just need the first like bunch of letters. So I'm just going to grab, I think you need 1, 2, 3, 4, 5, 6, 7, 8 or something. So now if I were to say something like git checkout and then that specific ID, it says switching to that, you are in detached head state. Tells you a bunch of stuff. It tells you some things you can do. I barely know about this part, but you'll notice now it says like git at this weird thing, right? And then the important thing to note is that if I do ls now, that's back to example.py. And if I were to open all of these up, we'll see that in example.js, it just has the old version of the code. So basically, we just rewound to where we were. But if I do git log, oh, even that is actually rewound too. So it's as if it doesn't know about the original. We just wound back. And this is just to sort of like in Git, you generally don't want to delete history. So once you did something, you did something. But you could go back, say, oh, there's these changes I got rid of, and I want to bring them back, and then you like copy those changes into the current thing, and then you commit that as a new change. In reality, this tends to be a pretty complicated way to do it, and GitHub is a better way to do it. So we'll kind of ignore this for now. We don't do a lot of rewinding locally. Generally, what you're going to do is just use that to like keep track of things. Even though it seems like that should be like the easiest thing to do in Git, to rewind, it ends up being kind of complicated. And like I've said, like I feel like I barely understand Git. It's very complex. And so very often you're like, oh, I want to rewind to this previous thing. You start Googling it and you get these results saying like, oh, you just have to write git reset dash dash hard dash. I don't care if this, completely destroys my history. And you're like, what is this? Why is it so hard to do it? But that's the reality of it. And I know firsthand, the most traumatic programming experience in my life, which I think is probably true for other people as well, is Git based. In that one of the early times I was using Git, I was using some kind of Git visual tool because I'm like, I don't need to learn this. I never want to learn this. And it did some stuff that I didn't understand. And for like a whole day, it seemed like I destroyed everyone's work for the last week. And I was like, I need to fix this. I don't know if I can fix this. And it was horrible. And that's what we're trying. Like basically, that's the main reason to be very careful with typing in Git commands, because it's sort of this this conundrum where it's like you're likely not going to understand Git deeply enough to know what every command does, but also you can type in commands from the internet that make irreversible changes that then like really mess things up for people. So it's a little complex, but for at least for a while, you'll only be working by yourself, so you don't need to worry too much about destroying other people's work. And ideally, once we use GitHub, everything is backed up. But I just showed how I would, check out this branch. So that's what git checkout is. We checked out that specific, not branch, we checked out that specific commit. But I want to get back to the main one. So you could also check out a branch, and if you check out the branch, you're checking out the latest thing on that branch. So now we're back where we were initially. If I say git log, I see everything. If I do ls, you'll see it's example.py, not examply. And now it's up to date. It's what I expect. And I think we're going to take a break in a second and then talk about the GitHub side of things. But before we move on, any questions about what we've discussed so far?
So are branches just like the main way you deal with all your different versions, just using different branches for different versions?
Yeah, essentially. We talk about branches a little later, but like if I were to write git branch, it just has main. And if I wanted to make a new branch, I could do something like, this is the main way you do it, checkout -b, meaning a new branch. And very often it would be like your main branch is like your production branch. That's like, this is ready for production. This doesn't have bugs. It's great. but you, the user, should really do stuff in the dev branch. So I might do that. And now you'll see I'm in the dev branch. And if I say git branch, I see I have more than one branch, but I'm on dev. And now if I started making changes here, they would only track here. So let's say I just did something like touch new file dot, JS. So I can add that file, and then I'll commit it, added file. And now if I say git log, it knows about that, right? But if I were to say git checkout main, and now I say git log, it doesn't know about that. So basically I can do work on another branch without affecting the main branch. And then once we show the GitHub stuff, we'll show how, or the modern way that you're supposed to take work from a feature branch, as we call them, and merge it into like the main branch. But yeah, it's basically where you would do work that is sort of experimental. You're not positive it works yet. All right, any other questions?
Yeah, so I'm a little confused about that with the branches and the commits. So like, what was the difference between like different branches and different commits again?
Yeah, I think I can show that here. So it's sort of like, let me move this stuff up a little. Sort of like this track represents our main track, right? This is our main track. And this is where head points right now. And then when I made a branch, it kind of went like this. It took the initial thing here, and it took like the initial thing here and it copied it. And now this represented the current state of this, of this new thing we called dev. This is where it starts getting time travel-y. So it's like I had my main branch and now I have this new thing called dev. And then I made a change that only exists on dev. And then, for a second there, head pointed to this. This is where I was doing work from. But then when I checked out main, now it points here. And so you can kind of have these two things going at once. And the idea is that you might make a lot of changes. So maybe I like make another change. And then at some point when it's ready, we take this change and we, send it back. So now there's so like basically now we're saying, oh, we made all these changes and we merged them into main. So now, whatever work we did here that we approved of is now part of this, is now the next version of main. Yeah, like there's a lot of arrows here. It gets confusing. I don't know if I answered your question, but we will talk about branching a little more in a bit.
Thank you.
How do we add that version back to the main?
Yeah, we're going to get into that more when we do GitHub. There is a way to do it locally.
Okay.
But I think something maybe worth seeing is like, if I go here, there's probably a way that I could see our commit history in a way where we see like all the branches and stuff. Maybe it's insights, commits. Dependency graph, is that it? Basically, we're trying to see, there's like visual insights into GitHub so that you can see all of the branching and what happened. Maybe if I do 8 branches. I might look into this, but basically there's often nice visual ways. So like visualize git commit history. I'm sure there's some way I can just with GitHub. It will look way better with GitHub. Yeah, this is what everyone's looking for. Click on Insights and then Network. Okay, looked like we were almost there. So it could just be that this takes a long time. No. How useful is this even? Not really. Yeah, I'm not seeing a great example of it, but there's ways you can visualize it that are like, this is what I'm looking for, something like this. And how do I see this? Oh, it's some kind of extension, I see. But as you can see here, like this is what makes it useful, that it's like, oh, you have these like branches and they branch off from each other and they merge onto each other. Because that's so hard to visualize in your mind. It's even hard to look at it like this, but it looks here like you have this main branch, which is red, or like you have this main branch, which is, or I don't know, you have purple and you got white, and then white, when you see like a curve there, that means like you branched to create a new branch. And then when you have something go into something, that's a merge. And the goal is that eventually everything merges into one timeline. But when you're trying things out, you might try things and, make some changes, and maybe you abandon them, or maybe you like those changes so they eventually come into the main branch. I'll see if I can download this extension before we get to the GitHub part of it, but we'll see how we combine branches. And also, when you're working alone, you do this way less. It's just we wanted to introduce you to it early on because it's been a complaint in previous cohorts that like Git is such a complex tool and nobody really understands it, and it would be nice to know a little more early on. All right, if that's everything, let's give you guys a 10-minute break. So let's come back 10:50. I don't know how I feel about this French extension with 10 reviews.
The TA sent a pretty cool extension for Git in the chat.
Oh, cool. Let me check it out. 1 second. Let's see.
You got to pay for it, but it's free if you have a GitHub student account.
Which I do not. I should look into getting one somehow. I feel like as a teacher, you should have the same tools as the students. Yeah, and I see. We'll hopefully talk about this a little later. Remind me to if I don't. Explaining the .git ignore situation, because yeah, often there's files that get pushed that you don't want to, even though most of the time you do want to do git add dot. Yep, we'll look into that.
Going back to what to Chris Wade said, with like mutability of like reference and those files, isn't it creating like a whole new reference to the contents of that file?
Can you say it again?
Like dealing with the like renaming a file, mutability of like reference, and so it's like creating a whole new reference to the contents of that file, right?
Not positive I know what you mean. It is it definitely, for tracking purposes, it notices it's a change. And somehow it knows that it renamed it, as opposed to that it's some brand new file. Which would imply it's probably reference-wise, like in terms of like memory location, it knows it's the same thing. It just knows it now has a different name. I'm not positive. Was that the question?
Well, I'm just curious about that same question because I think like you said, it's still the same file, but like the contents of the file are like stored separately, and then like the name is just like a reference to it.
Mm-hmm. Yeah, so we get into this a little bit more in week 2, but essentially everything in a computer lives in a specific memory location. And that is the ultimate unique identifier, because only one thing can live in a specific place in memory. So what likely happens is that and that's what I thought you meant, because the word reference in computer science generally means the memory location that lives. So it's likely that in that .git folder, it has a memory location, a name, which is just like a handler for that memory location, and then the actual contents of the file. And so what probably happens is that when you change the name, initially it says, oh, I guess there's this new handler with, the same contents. So like, I wonder how it works exactly, but it's able to know it's the same because it points to the same place.
Right. Yeah, I think like what he was saying, because they are strings, so they're like immutable data types. Like as far as I'm tracking, like I don't know of like a limit to characters on the names that you can like name something.
Mhm.
So I'm just like speculating here, but my guess is that there's a pointer to the name, and then by renaming it, it's pointing to another name.
Pointer to the name. Yeah, I mean, if we were to open up like Visual Studio, and maybe like, not that this is a JavaScript thing, but if we were just to start writing in a language, what is that? If we were just, it's sort of like we had this thing called examply, like it's almost like we have something like let examply. And what is examply? Well, it's like an object, and that object has like a name, which would be examply, and then it would have some contents, which is some whole big thing. And then it was like we made a new thing where we said like, let example equal this thing. And initially, like, because every object lives somewhere in memory, these are not the same thing because they point to different memory locations. But then when it realized it was a rename, it's like saying example equals examply. And in that case, everything from here is now in here. And this is literally pointing to, like, these are just handlers pointing to the exact same thing in memory. So
Allocating the memory to example and then dereferencing examply and referencing example.
Yeah, but this is where it gets sort of complicated, that like the terms you're using about like referencing, dereferencing, those are ideas about like memory allocation that just you as a JavaScript or Python user never touch that directly. And then the idea that like strings are immutable. Well, strings are immutable in a modern language like JavaScript or Python because that's a really intelligent move, but strings are not immutable in C. And at its core, nothing is immutable in a computer. It's just it's literally just transistors that hold an electron or they don't. And the CPU has the power to flip any of them on or off. So it's like all these rules are only rules in a modern language or a modern operating system that is enforcing intelligent rules. But like at the end of the day, strings are not immutable. you can go to the memory location where that string starts and just start changing things. And that's why languages like C are responsible for like most of the security issues in the world, because you can do all this stuff. You can just overwrite things. Like technically you shouldn't be able to write past an array, right? If an array has 10 spots, that's where it ends. Well, not really. There's a memory location after it. So, you know, you can write over it. And that's virtually all of hacking, is a matter of taking advantage of the fact that these rules are not hard and fast. At a really low level on the computer, you can break all the rules.
Yeah, I think I did that back in the day when I created an infinite life hack in an old Harry Potter PC game. I just kept rewriting the life on there.
Yeah, and I bet like that Harry Potter game, because it's a game, it's probably written in C or C++ at its base. And the reason games are made in those languages is because every ounce of efficiency matters. You can't have any amount of slowdown, because like a language like JavaScript or Python, it uses what's called a garbage collector. It's basically every minute, 2 minutes, it's like doing this little thing for you where it cleans up the memory, it releases references that are not used anymore. But that would slow down a game ever so slightly every 2 minutes. Nobody wants that. But as a result, that game opened itself up to weird stuff where you could just inject a line of code, and it's like the biggest issue with C and C++ is that it will yell at you and break the program after you break a rule, but you break the rule first. And because of that, it's like a lot of hacking is possible. Yeah, but that's fun. That's fun that you learned with a game like that, because like modding a game is among the hardest things to do, because it's just like I can't even, like, what were you modifying? Was it code or
So this was many years ago, but I was just basically like a little script kiddie. I went and I found this program, and then all it would do is analyze the memory. So I would tell it like, hey, look for this value, and then I would run it, and then it would select all the memory addresses that had that value, and then I would just change my life a little bit, take a little bit off, and then so get damaged a little bit in the game. And then I would find that new value again, and then it would go from those memory addresses that it already found and keep shrinking it until I found the exact memory address. And then I just created a script or a program that would overwrite that memory address with the full health value.
Yeah, and you did that in like C or?
So I think there was obviously that tool, and I think I did that in C++.
Okay, yeah, but same difference. Like the fact that it let you say,
Right.
hey, I want this specific memory address and I want to write what I want to write there. You can't do that in most languages.
Yeah.
Anyone?
I guess the new language, they don't have pointers anymore, do they?
First of all, who's asking? Because was that
It's
there?
me.
Okay.
Myself.
For whatever reason, sometimes it doesn't highlight the whole person. It just shows a little yellow bar below them. Modern languages don't have pointer manipulation, as in, you know, if you go into, if I were to go into Python, for example, so I can go into Python like this, and then I would say like x equals 1, right? And then I could say ID of x, and that's exactly where it lives in memory. The difference between, so it definitely, you know, it still references things in memory, but it sort of shields you, the user, from messing with that. What you can do in C, which you cannot do in a modern language, is something like saying, you know, get me this memory address, add 1 to it, and then I'm going to write what I want to write there. Like you can't just arbitrarily access memory and put something there, because that's what all computer security issues are made of. So there still are pointers. It's just you, the programmer, aren't allowed to do pointer arithmetic, as we say. Yeah. For anyone joining now, you didn't miss anything essential. Just questions about stuff that is a little too low level for this course. But yeah. let's get back to it. Hope everyone enjoyed their break. Okay. So where were we? First off, am I sharing my screen right now? I am, yeah. Okay, just gonna quickly look at the chat. Okay, so let's put this aside. Right, so where were we? Up until this point, we have everything we've done is just git local on the computer. We discussed branching ever so slightly, which we're going to come back to. But the basic idea here was that you have this one branch and you're able to make changes to it. And it's just a way to like keep track of your work. But I want to open the floor for questions about everything we've discussed up until now before moving on to where GitHub fits into the picture.
Do you know anything about submodules? I had a student who accidentally created a submodule in his repo and he couldn't access his code.
Submodule. A submodule, do you mean somebody made a Git repo within their Git repo?
Yeah, I think essentially that's what happened.
Yeah. So basically Git doesn't like that because it breaks the whole idea of like tracking, because it's like you're tracking something specifically within the thing. So basically a given folder that is a Git repo represents the whole repo. Any changes to it are represented for that whole thing. If a folder within the folder you create a Git repo, it's going to start yelling at you. And the solution is you delete the inner Git repo. So I mean, I can even show that right here. If I said make dir inner repo, and I went in there. So like if I go up a level and I say git status, oh, I think because inner repo is empty. So I'll go in there and I'll say touch inner file.txt. If I say git status, even from here, it looks a little confusing because of where we are. So I can go up a level. But when I say git status, the whole Git repo, my first repo, says, hey, you added a new file. Let's track that. But if I went into inner repo, and first I'll show you ls-a, it just has inner file, right? But if I say git init, now this is also a Git repo. It has the .git in there. So now let me go up a level. If I say git status, it knows, it's like, oh, you want to track that new file? And if I go inside it and I write git status, it thinks it's its own thing. And so you get into this weird thing where like if I were to go up a level and I say git add, it doesn't like that. It's saying like, I mean, it's a weird way of saying it, but it doesn't want to add it because that's its own repo. It can't be responsible. Like it would just, it gets, I don't know how to put it, but those two things might track separately. So it doesn't like that. And the only solution is you go into inner repo and you decide if inner repo is its own thing, move it somewhere else. If inner repo is not its own thing and it should be tracked by my first repo, you just remove the .git, and then you go up a level. And now if you try that, the git add, now it understands. So yeah, you cannot, you'll run into these issues eventually, and that's how you learn generally, but you can't have a Git repo in another Git repo. It just breaks the contract of Git. Okay, so we feeling okay to move on to GitHub or any more questions? I'm gonna guess that we're ready to move on. Cool. So And I see I'm here right now. Let's say I don't actually want that. I can remove that. And there's something inside of it, so I'll remove it entirely. And I'm removing it on my file system. Oh, I guess because I committed it, so now it's saying, and that's why you have to just sometimes read this stuff. So it's saying like you said this would be committed, but it doesn't exist it's going to have trouble because it doesn't exist anymore. Oh, I think I just need to do git add dot now because it's saying there's this new file, but then there's this unstaged change where I delete that file. So now that I do that, it knows that there's nothing to change. I say git log, I'll see all my current changes. Cool. So now the question is GitHub. Well, GitHub is a website that allows you to back up your local Git repo, as we say, remotely. So it's only so useful if it only lives on your computer. And I feel like most people wouldn't use Git for most things if it only lived on their computer. But having it live on GitHub means that it's easy to share it with other people. You could have other collaborators, and you just always have this like official history. So I think the first thing I'm going to do then is maybe I'll move this here right now. It's almost like there's too much on the screen, so I'll just close that for right now, and we'll open this. And we're going to go to github.com. And now what I'm going to do is this is my own, GitHub. That's me. So I'm going to click this plus, and I'm going to select new repository. So you do this less often when you're cloning from other people, but if you created something initially on your own local computer, you did git init, if you want to hook that up to GitHub, the way you do that is you first create a new repository in Git. And I can call this whatever I want. I guess first I'll choose the owner, which is me. And if I say my first repo, something tells me I've done this before, so it's going to say, you already used that. No, it's okay with that. I can give it a description I want, but I won't. And then public means anyone can look at it, but I, of course, can, as the owner, will choose who can commit. Private means only I can see it. Private kind of makes more sense by default, but if you create too many private repos, Git says, hey, that's enough, or GitHub says that's enough, we're going to start charging you. So that's the main difference between public and private. Public, everyone gets to see it, but if it's not sensitive or whatever it is, just let everyone see it. And we're not going to choose to initialize it with anything. We're just going to leave it as it is. And this license thing is basically that automatically puts a file in there to tell other people what their rights are in terms of copying it or not. So like the MIT license is the most open license. It says, it's like legal speak. I've never read it, but it basically says anyone can copy this code, even for commercial purposes. And then there's other licenses in here that say like you can copy the code, but only for free purposes. And none means I haven't said anything. So theoretically, if you copy this code and make money off of it, I can then sue you and say, hey, you owe me some money because I never specified. We're just going to ignore that for now, because as it turns out, my first repo is probably not going to be a moneymaker. So not a big deal. We're just going to create that repo. And then you'll see a screen like this, which is a little odd because you're used to seeing a screen where it like shows code and stuff. And the reason for this is because there's nothing in this repo yet. It wants us to set things up. And you can follow these instructions, and that's what I'm going to do now. But we're going to follow these instructions, as in we already created a local Git repo, and now we just want to push it to GitHub. So we're going to go here, and we're going to copy this, which is like the address of this Git repo. And then we'll use some Git commands to hook them up to each other. Okay, so I'm going to open this up again. And I'm going to go back to that my first repo. Here we are. And now what happens if I type git remote? So remote means, where Git can push things to. So we talk about pushing and pulling, and that means you know, I'm on this computer that's local, but remote would be somewhere else, some other source of truth. So if I say git remote, I see nothing because I have nothing remote. Let me see, if I type git remote -v, still nothing. Okay, so what it wants me to do is, and we will see, this is the exact same instruction here, git remote. These are all subcommands, add. So we want to add a new remote location for this Git repo. And then origin is the name of it. Just like main is the default name for a branch, origin is the default name for your remote. Because generally you're just going to have one, and so you call it origin. And then finally, the location. So I can just copy paste that whole thing. So git remote, add origin, that location. Great. And now if I type git remote -v, that's going to show me all of my remotes and some information about them. And so it's showing me that I have this remote called origin, and this is its location. And it's showing it to me twice because it's saying I can fetch, meaning I can grab that code from that location, and I could also push. I can push my own code to that location. I've never seen these two not together, but I suppose it's possible you could have a situation where you're allowed to pull from something, but you're not allowed to push. And pull and fetch are like the same concept, just pull mean, it's not worth getting into. Like pull means grab that code and make it part of my local, whereas fetch means grab that code, but then don't do anything with it, which is sometimes what you want, I guess. Okay, so now what we want to do is we want to take this code we have here and we want to push it to GitHub. So first, let me just try typing git push. Doesn't like that. It says you're on branch main, but there's no upstream branch. So what does that mean? It's saying that like you have this thing, this remote called origin at this location, but it doesn't have a branch called main. So when you said git push, you're on the main branch, you're trying to push the main branch, but where? So this is a little pedantic, but it wants us to do this. If we look at this, this is the same thing. You can ignore this thing. This is just telling you to rename something, the master branch to main. But this is saying git push, and the short version, upstream origin main. But we'll write it out just like they say, or we can even copy paste it. So what this is going to do is it's going to push the current branch main to origin, and the branch it's going to push to on origin is also called main. And then this command here, set upstream, sets up a link there so that in the future, the main branch on my local and the main branch on my remote, they know about each other. So if I say git pull, it's going to pull from the main branch. If I say git push, it's going to push my main branch to remote's main branch. So I do that, and it says all of this. And now if I go back to my site, I can reload it. And I see that I actually have everything there. And I am on the main branch. And this main branch is not identical to my local main branch, but now they're hooked up to each other. So looking through this, like something I could see is like, okay, so I set it up so that I could do git push. And let's say I try and do git push again, it's going to say, well, everything's up to date. And maybe I say git pull, meaning get everything from the remote main branch from GitHub. It's going to say everything's up to date. But that's not always the case, especially if you're collaborating with other people. And I can sort of mimic that in that you see here it says like, you know, hey, you might want to add a README. And you can make some basic changes to your repo on GitHub itself. So I'm going to say, okay, add a README. There's a file. It's going to be called README. It, you know, filled out a little, but I'll say, please read me. I need validation as a README. Okay, it's a little psychological. I feel bad that I wrote that about this README because like he needs help and I'm not necessarily providing it. I'm sort of mocking him, but we're going to write commit changes. And just like you did it locally, now you're committing a change, you know, on your GitHub side. You're saying we created a README. I'm not going to write anything about the description, commit directly to the main branch. Okay. Cool. And now if I look here, I'll see I do have that README. This is how GitHub shows a README. And it's also an actual file that lives in the repo. And now the most up-to-date thing is that I created the README. And if I look at the history, I'll see that, these two I did locally, but this one I did remotely, and this is part of it. So now I can go back here and you'll see that if I'm in my first repo, if I say git log, it still only knows about those two. If I do ls, it doesn't know about the README. But if I say git pull, because I did that upstream thing before, it knows that the main branch, it only has one thing called origin. So I don't have to specify. And it knows that this main branch is hooked up to that main branch. So I say git pull and it grabs that stuff. And now if I say ls, I actually have that README here. And by the same token, I could say touch example dot example dot JSON, and maybe I open up example dot JSON, and I'll just add some JSON, and it'll look like hello world. So JSON's just like a data format. And I'll add that one, and I'll commit it, added JSON. And unlike before, now if I write git push, I already set it up so it's simple. It knows exactly where to push, and I can reload this, and that file is now here. So as long as you're working by yourself, this is generally how it's going to go. So I guess before moving on, any questions about what we've done so far with GitHub in terms of the git push, the git pull, setting it up?
I had a question. So yesterday, like when I was doing like the commits, you have to push those to GitHub for it to update on GitHub, right? But like the commits like just kind of live on your desktop version. Is that correct?
If I understand you correctly, things only live on your desktop until you push them. Yeah. Was that the question?
Yeah, that's what I thought. Like it wouldn't update just automatically like those commits. You have to push them.
Yeah, exactly. And the reason for that is that once you're collaborating with other people, you might try and push, and then you'll see that there's a conflict, as in someone else did some work and your work is not, like you both touch the same file, let's say. And then it can't simply sync it. It needs you to sort of manually make changes for fixing what they call a merge conflict. And that's why it can't just sync automatically in the same way that, like, if you're writing something on Google Sheets, every time you type, that's being saved. And you can like roll it back and stuff. But because there's multiple collaborators and because you're not working together at the same time, it's sort of like locally you could do some work and someone else can do some work. And that's actually like a positive feature, that you guys are not, so synced that you're stepping on each other's toes. And it's only once you try and, push your code that you might find out, oh, he already pushed his code and he made some changes that aren't compatible with my changes. So if I want to push my changes, I need to first git pull his changes and then, see how I can put it all together.
Is there some kind of concept just you can just check out and put log on the specific files while you're changing it?
You're saying, is there any way that you could like lock a file and say no one else can change this?
Yeah, while you're working it, for example, you worked like for a couple of days and you want to push it and you find out that somebody already changed it different in a conflict.
What you're describing is a very reasonable approach, and that's that is not Git. So there's other types of version control that aren't really so popular anymore, but that's how those versions work. They basically said, if someone checks out a file, it's their file until they're done with it. It's locked, right? No one else can change that file until this person's done. Otherwise, you're going to step on each other's toes. And Git takes a different approach, which says you can both take it out at the same time, but whoever pushes first decides the truth. And then the next person has to make sure they pull to make sure that it lines up. And it's a more complicated system compared to the locking system, but I guess it works better for like really large, really distributed teams. But I can tell you that when I worked at Microsoft, we didn't use Git because it was before they bought GitHub. And we used an internal version control thing, and it worked like that. You know, you took out a file, it was locked. You own that file until you made changes. Okay, any other questions, or should we move on to the rest of the lecture?
I want to ask something real quick. I just want to make sure I understand. So when we do our assignments, we pull from the uniform repo, and then we do commits in our local Git, and then we push that commit back up to the uniform repo on the main branch there, and that's how you guys see our assignments. Is that how that works?
Yeah, so when you do your assignments, because we're using GitHub Classroom, it's like it's already gonna make a GitHub version for you right away. So the first thing you do is you clone it. And cloning just means you're pulling from something that you don't yet have locally. So once you clone it, you have it locally. And then from there, you just make changes, you add those changes, you make commits, and then you don't have to push all your commits right away, but when you're ready to push, then you do git push, and then it will update it on your GitHub repo. And there's really no reason you'll ever have to pull, because your GitHub repo is like the source of truth, but you're not really making changes there, and no one else is making changes along with you. So for the most part, you're just going to be pushing there, and it's just for posterity.
Okay, so if you clone it, you don't need to create a repository, right?
Exactly. So the way that like if I go to Classroom, so if I go to Classroom, let me just grab a random one. It'll be some pairs, right? So I click here. And I'm not on the list, so I skip. And I accept it. And I wait a second and I refresh. So this actually, this process already creates a repo for me. So this repo already exists on GitHub. And because of that, I don't need to do the, the plus new repository. That was just showing you how it, would work from scratch. But in this case, it already exists. And in that case, I just go like, GitHub CLI or HTTPS. I'll do it this way right now. And then from here, I could write git clone that repo. And now I have it locally. And this is what it is. And maybe I go into, maybe I open it in code. Maybe I go into the JS and I go in here and I write console.log. I'm not doing this assignment. I save it. And now it's ready for adding and pushing. So if I said like git status, it knows all that, and I can do it all here. I will do it here. I'll do git add dot. So now it added it. And I can see that again with git status, and I can do git commit -m made a change. And now if I type git log, I'll see all of this stuff was done by us, but then you just made your own change. And so at that point you can write git push. And now if we go back here and we reload, it actually knows about that change. And if I go into JS and I go into some pairs, that change is there. Something probably also worth mentioning while we're here is that I just did that, but let's say let me write another line, which is const x equals 1, x plus equals 1. Whatever, I made some change, hit save. I could do what I did before in the command line, but you'll notice Visual Studio Code's pretty smart. It actually knows, wow, this is a Git thing and you modified this one line. And then over here, if I click on the source control thing, it actually knows about it. It says like, hey, you made this one change. And so I can click plus, and now it's staged that one change. And now I can say made another change and hit commit. And now I made a commit. And you'll see if I go here and I do git log, it actually knows about it. So it's the same exact thing. You just want to be careful with complex scenarios, but using a visual tool, but the visual tool works. And now I can click that button and it says it's syncing it. Let's read what this is saying. Would you like it to periodically run git fetch? I'm going to say no. But now if I go back here and I reload, it has that change. So once you feel comfortable with it, you can just do it that way in Visual Studio Code. We just like you to know what's really happening behind the scenes first, because that's all Visual Studio Code is doing. And I believe even if I go here, I'm pretty sure a way I can like show git output. And as you see, it's doing kind of more complicated stuff than we know about. So it's not doing the exact commands I showed you, but we sort of trust it knows what it's doing. But that's the real fear when using one of these visual tools, that like, if it does something wrong, you got to know what all these random commands are, and I don't. Yep.
So what would be the difference between that and forking on GitHub?
Say that again.
What would be the difference between that and fork button on GitHub?
The fork button on GitHub?
Mm-hmm.
Yeah, so the nature of the fork button is that that's just GitHub to GitHub. So I need to make a setting change that you guys can't make, but I can make so that that's possible. How do I allow forking? Okay. But if I go back here now, like I'm going to go to this project right here. And this project lives on GitHub. Everything I just did there, that was locally and pushing it from local Git to GitHub. Whereas this project lives on GitHub. And if I were to fork it, forking is saying I'm making my own copy of it. I can select who the owner is. So the current one was owned by Uniform Platoon Assignments, whereas this one is owned by my personal one. I can change the name of it if I wanted. And then I can click create fork. And now if I look here, I have my own version of it. So that's what forking is. It's not really the same concept, but forking just means GitHub to GitHub. You're going to get your own separate copy. And as you saw, not every organization on GitHub has to enable forking. But let's say I was going to go to like Facebook React, right? It's got to be somewhere. Yeah, and let's say I was going to say like, you know what, like apparently 43.6 thousand other people did. I'm going to say, you know what, I don't think Facebook is taking React in the right direction. I'm going to make my own React. So I click that and I say, my own name, and then I say React. That's a bad name. It should be Benjamin Cohen React. But I leave the description, and then I'd say create fork. And because Facebook allowed that, it's probably going to take a little longer because there's way more to copy. But because Facebook allowed that, I'm allowed to do this. And this is my own version of React now, so I can start making my own changes. And if I cloned original React and I made some changes and I tried to push them, it would say, sorry, like you're not on the Facebook team. We don't know who you are. You can do a pull request. We'll discuss that. But basically, you don't have the right because it's not your repository. We don't know who you are. Whereas in this case, I have the right. I can make any change I want, including breaking it. And it doesn't affect anyone else because as you see, like I forked it, but nobody's watching mine. There's no stars. No one really cares about this repo. They care about the original. But then again, if I make my own changes and I'm like, you know what, Facebook made a few of their own updates and they're good, I can just click that. And if it was behind, it would sync it, so I would get all of their changes. But that's what forking is. It's basically a way to get your own version of something that someone else made. And when you push changes, you're pushing them just for you, not for anyone else.
So if you went to like your repositories, this would show under there.
Exactly. So
Okay.
I'm going to look at Aloof Buddha, and I'll look at repositories, and Benjamin Cohen React is right there. And actually, deceptively, it looks like I did a lot of work this past year, but I didn't. So that's funny that when you fork, you get all the, but I'm assuming if I look at my actual, it's not going to imply, no, it doesn't, of course. Yeah.
Yeah, actually, I had a question about this. You just brought it up. Everything we did with this assignment, it doesn't show up on the status on ours.
Sure.
Is it some kind of bug, or is it normal, you know?
You're saying that the work that you did yesterday that you pushed is not showing up as your own as contributions here?
There's nothing in the June on my status.
Yeah, well, Francisco told me that it would show up, but if it's not, that's why I would recommend forking, because forking now, you own that repo. But according to Francisco, it should be recording it as a contribution. And I'm pretty sure, like, right here, it says that I contributed to Code Platoon curriculum. I'm not actually sure. Yeah, we should look into that, because it's not so essential, but you might as well be getting credit. And forking is such a simple thing. But yeah, we'll look into that. Okay, so enough of that. The last thing we wanted to talk about, I guess I have it on a different page. There we go. So we did a bunch of stuff there, but let's just finally finish off with this Git branch stuff. So I want to show the process of, and you're not going to do this for a while probably, but it's worth seeing the final product, how you actually, would make changes on a team or something. So if I look here, I have this, and if I say Git branch, I'll see I have dev because I created it before. But if I didn't, I would say Git checkout -b dev, and that would have made a new branch called dev. And then if you want to go, that thing above would create it and also check it out. But if it already exists, you do something like Git checkout dev. So now I'm on the dev branch, but I haven't done anything on this branch. So maybe I want to make some changes here. Like maybe I'll open up that new file.js, and I'll just write, x equals, let x equals 1, x plus equals 1. Doesn't really matter. I'll close it. And then back here, I can say git status. I'll do git add dot, and I will commit that change and say new dev branch change. And I'll say git status. So at this point, I made a change. So if I do like git log, we'll see this changes here, and that change would not be represented on main. Like if I check it out real quickly, I can go to main. I can say git log, and that change is not there. But what I'm going to do is I'm going to go back to dev, and I do have that change here. So what I want to do now is actually push that change. So I might try and do git push, but once again, it says we don't know about this branch. We've never heard of it. And that's true, that if I look at wherever my original thing was, and if I do git remote -v, that'll actually tell me that's exactly where it is. So just not including the .git part, that would be the URL I would want. So if I look here, I have branch main, I don't have branch dev. So I want to actually, push these changes to a new branch called dev and set up that relationship. So that's what this does. And now I'll go back to Visual Studio, and it'll see dev has recent pushes less than a minute ago. And I'll see that I can actually, maybe I have to reload. but I actually can see the dev branch. So like that one file is not here, but if I go to the dev branch, that file is here. But then something you see that you'll only see on GitHub is this compare and pull request thing. And this is how things are generally done in professional circumstances where like you made this change to the dev branch, but the dev branch is just sort of this temporary thing. So maybe you want, you do what's called a pull request. You're not pushing what's on dev to the main branch, but you're requesting that it be pulled into the main branch. And so you set up that request. And in the real world, we would add reviewers. So like if I had other people on my team, I would generally be required to add like 2 reviewers, and they would both be required to say, yes, that change is legit. And only then can you finish the request. But you'll see here, it says like we want to pull into main. And what we want to pull into main is the current state of dev. And I could write a little bit and then I create the pull request. And then we see this where if there were reviewers, they would have to review before this button would be green. But they could look at this, they could see the commit history for, for this branch. They could see what files I changed and what lines in those files. And that's what a code review is, someone reviewing this. And it's trying to, GitHub itself is trying to say like, hey, you probably want, if this is a professional project, you probably want to make it so there's like a rule where you require approval. And they're saying like, branch protection rules make it so that not just anyone can do this. And of course, if I click on this, they're going to say like, I'm almost positive they're going to say like, hey, don't you want to upgrade to, your GitHub free plan can only enforce rules on its public, whatever. Oh, I actually can do it on this one because it's public. Okay, good to know. But for right now, it's just imagine, I passed all my reviews. So now I can say, okay, we're ready to merge the pull request. I could also close it and say, turns out people don't like these changes and we're just going to abandon it for now. But I can say merge pull request. And, this is all the info. And I say confirm merge. And then at this point, it's saying like, you really want that dev branch anymore because whatever work you did on it has now been merged. So maybe I want to delete it. But I'll just leave it there for right now. And now if I go to code, I'll see that the latest change is that I merged those changes. That file is in there now. And if I look at like the commit history, I look at the commit history. I don't know why that's not working. Let's try that one more time. There we go. So yeah, and I downloaded that extension. So basically you see I have like the main branch, right? And then there's this dev branch that it split from the main branch here. And then I made some changes. And then I also made some changes on the main branch. And then I combined this version of the main branch and this version of the dev branch into the main branch. And so it has like 2 parents. It gets a little complicated, but basically this is how people keep track of things. And for comparison, if I were to go to Facebook React, because that's probably the biggest individual project I could think of, I could go into commits. Why am I not seeing commits? Is it not big enough? There we go. This might take a second. And there's going to be so much, like to the point that it actually can't show it very well. But we're basically seeing that there's like this, there's these different, it's not showing it too well, but like there's this branch over here and it's called RH/add off-screen text. And that seems to end there. And this one was recently pulled off, TY, and it's doing something, but it hasn't been merged in yet. And I mean, I think basically there's too many branches to see it because there's like so many branches in React. But essentially we're like seeing how everything comes together. But yeah, it might not have been a great example because there's way too many branches, and I'm not sure I know how to like, okay, there we go. So let's say I just want to say the main branch and whatever this is and whatever this is and whatever this is. Not sure if that is doing what I asked it to do. Okay, let's not worry about it. But hopefully that demonstrates some stuff about branching and pull requests, which again, you're not going to use too much right away. But it's worth knowing that that's where it all heads. That's like GitHub becomes a very useful tool for teams to collaborate. And Git is the basic, command line tool that lets all that happen. And just to review, these are the essential commands that we discussed today. So we have like a little less than a half hour left. We can review some stuff. I know some people mentioned what happens if like you add something that you didn't mean to add. And I see some people saying mine didn't either, so I'm curious what they're talking about. But I did want to show you at some point this idea of git ignore and how you might remove a file that you accidentally added, like .ds_store, which is some like random Mac only hidden file. But before we do that, any questions on, just general questions on what we covered today?
Yeah, I have a question about, do you remember when we cloned
Yes.
curriculum?
Yes.
There was like GitHub's own like CLIs over there, like GH repo clone. Is it the same thing saying like git clone, or it's a different? Like when you clone it?
If we went to curriculum, for example.
Just code.
So this right here, this HTTPS thing, that's the standard way. And this way we take it like that.
I'm talking about the GitHub CLI.
You're asking about the GitHub CLI, you're saying?
Yeah.
Yeah, so with this way, we do it like that. Git clone, and then that specific URL, and it takes a minute. And now we have it here, but I am actually going to remove it because we're about to do it again. So your question is, what about the other ways? Well, first there's this SSH thing. Not really worth getting into, but SSH stands for Secure Socket Handler. It's a very secure way of doing things, and it's sometimes the only way. But as you can see, you have to like create a key and all this stuff, and that can be a little confusing. So the third way is the GitHub CLI. Part of the install fest mentioned downloading this program called GH. And I actually have it locally at this point, GH, which is GitHub's own command line interface separate from Git that allows you to work with GitHub through the command line. So like, just curious, okay, that's where my GH is. But if we do it that way, we can just copy this whole thing. We go here, and it does the exact same thing. It's the same thing. It's just that GitHub tool, if you set it up, it allows you to like set up authentication so it knows exactly who you are according to GitHub. And it's sort of like the best of both worlds. It's like Git clone, but it has the security of SSH, and it's like a command line tool. But really, these are, in general with computer stuff, these are all just tools, different ways of doing things. If something works for you, that's what matters. So don't feel obligated to use one or the other. And early on, it's easy to get caught in the trap of saying like, what's the best practice? What's the right way to do it? In reality, the way to determine best practices is do it the way you want to. And if you start running into the same problem over and over again, you now are learning, like you can Google it, find out a different approach, and now you learn to best practice for yourself. But don't worry too much about the right way to do it. Just make sure you have a way to do it.
I have a question. So if you clone an entire curriculum and you're trying to access a specific assignment, do you have to create a repository for that?
I don't think so. You're saying that if I clone the whole thing like I just did,
Mhm.
and then I want to access what?
Like an assignment, for instance, like first assignment. So do you have to create a repository in your GitHub to make changes to it?
Well, the way we set it up, it's that like this curriculum thing, we only expect you to pull from it. So if we ever made changes, you can write git pull and you'll get those changes. But if we actually open it up, what you'll see is that we don't actually put the assignments directly in here. We only link to the assignments. And when you link, like if you, let's say like day 2, let's say I'm going to go to, I'll go down to the bottom of the page. So like this thing here, we're actually not, this is linking to the GitHub Classroom thing, and you would follow that whole thing, and that would make your own repo. So that way you're not running into a situation which we had in previous semesters where people make changes to that same curriculum repo and then they want to push it, but they can't push it because, that would affect everyone. So this system we have now means that you're going to be creating your own repo like this. And once you create this repo, this one you just clone. And I believe in this one, there's not even what to push necessarily. It's just like an explanation of how to do it. But if we did want to push to this one, maybe I would touch text.txt. That should be enough. And then I'll add it. Oops. Yeah, I'll add it. And then I'll commit it. Added something. And then I'll push it. And because we cloned it, it already knows about the connection between the two branches. And now if I reload this repo, I have that new file here. All right. So any other questions about the stuff we discussed today before we move on to talking about the .git ignore stuff, because I know that was mentioned in the chat. Okay, so if we're going to move on to that, I could just use this one as an example. So just want to remember where it is. I'll go back to this. We'll just have these two open at the same time. Okay, so this is my, the repo I'm working in, and we have the same repo represented here. And let's say while making changes, I did like git add dot, and it added something I didn't mean to add. So an example of that, I'm on a Windows computer right now, so you won't see it, but a really common one is that if you're on a Mac for their own internal purposes, uses a hidden file in every folder called .ds_store. So let me just mock it by creating that myself, .ds_store. And maybe let me open up text.txt and just like write something in there. So that's another change. So now if I type git status, it knows about these two changes. One of them, it's already tracking because I modified something that I previously added, but it's still not staged. So I could, of course, write git add text.txt. And now if I check it, that's all that's going to be added. .ds_store is not being tracked. But because it's so common that you do git add dot, what's actually going to happen is something like this. And now if I were to notice that, I were to say git commit -m changes, git push. Now I can refresh this and I'll see .ds_store is there, and maybe I don't want it there. So there's a few things to do. The first thing is this file called .gitignore. So I'm actually going to create that file now, code.gitignore. And I can add anything to this file that I don't want. Like anything in this file that matches that I don't want added, it won't add. So I could say something like .ds_store. And maybe I would add, a common one is to add node modules, because if this was a JavaScript thing, I wouldn't want to add that. So now if I type git status, it knows about the .gitignore, or I can add it in a second, like git add dot. Now it knows about the .gitignore. And just because I added the node modules thing, I want to show something where, let's say this was a JavaScript thing, I would maybe do npm init-y. That's just going to create a dummy version of that. So now if I say ls, I also have this package.json in there. And let's say I were to say npm install react, right? Now, if I do ls, I actually have this thing called package.json and also something called node modules. And as it turns out, node modules is very big because it has all my dependencies, and React is a really big file. So now if I do git status, I see it saying like, hey, there's 2 more things we haven't tracked. But notice it's not even trying to add node modules because we have that in the .gitignore. So now I'm just going to write git add dot. And maybe I want to commit all these. Git commit -m even more changes, and then I'll push it. Okay. And now if we go back here, I'll refresh. Now, what you'll notice is we didn't push node modules, even though it is here, and that's good. But it looks like we do have the .gitignore here, which shows the things that we don't want added, node modules and .ds_store. But notice that we still have this here. And that's because if you add something to .gitignore after you accidentally added it, it's still being tracked. It's not just going to remove it. So what do we do about that? Well, the solution of that is that we actually, so if I did ls-a, I would see it's still there. And what I want to do here is I want to say, first I want to remove it as far as Git is concerned. So I'll say like git remove and .ds_store. So now if I type git status, it actually knows that you want to delete something. So now I'll say git add dot. I actually don't think I have to do that because it already has that one change. So I can actually just say git commit -m deleted hidden file. Going on here. I deleted hidden file I meant to ignore. And now I'll push that. Now if I reload, it's not there. And that was how I deleted it. But because it's in the git ignore, even though it's technically still there, and Git knows to ignore things like .git, for example. But even though it's in the .git, or wait, is it still? It looks like I removed it, but okay, so I removed it, but it's still in the .gitignore. So if I say git status, it doesn't know about anything, but let's say somehow it accidentally got added back in. Because it's in the .gitignore, it's never going to try and add it again. The only reason I had to do the git remove thing is because I added it first by accident, and then I added it to my gitignore list, which is why it's a good idea early on to add a gitignore list and add the things that you want to ignore. But it's pretty straightforward too to remove something after the fact. And yeah, that's it for .gitignore and that issue of like hidden files.
What about a global.gitignore file?
The global .gitignore file. What do you mean?
You can create a global.gitignore, so it'll be for all Git repos on your machine.
That's really smart. Yeah, I didn't know about that, but it makes sense that exists. So you're saying like, how does that work exactly? Like global git ignore.
I think GitHub themselves have a good guide on it.
Okay, let's look for that. Yeah, so this looks like this is a thing where, it looks like theoretically I could go to my root, and then maybe I'm going to, it looks like it wants me to first create a file at the root called git ignore underscore global. And then I could say git config dash global. Get that out of the way. So I wouldn't have known about this either, but very often with computer stuff, it's out there. And then I want to make it do that file I just created. So I'm saying that this file is my global git ignore. And now I could, go to that file. And then maybe from there, I would add something like node modules. And I would say, just never include node modules. I never want you to do that for any file. And now maybe I make, I'm going to make a new repo called another repo and get in there. And this one, again, I'm going to make it, oh, I do want to first do git init. This is going to be a git thing. And then I want to do npm init. -y just answers yes to everything. This is just so that I have, this is like a git thing. And now I'm going to do npm install react. Okay. And now if I look at this, I see I have node modules, package lock.json, pack.json. So at this point, I'm going to try and do git add dot. And if I look at git status, it looks like it did add all my node modules. So I'm not sure if I just made that. It looks like this did not quite work. And I wonder why. Is this only if I'm using git bash, maybe? Well, I'm sure there is a way to make it work. Positive, there is something. I guess we can go back there to that, to our root, and it was, I did git config dash global core dot exclude file. I wonder if it makes any difference that I do it like that. I don't think it should. And maybe like if I want to learn what everything for the git config is, I'm not even sure how I would look at that.
I think you need to use the there's a special Windows path you have to use.
What do
It's
you
at
mean?
the bottom of that website.
Here?
Yeah. Did you do it that way?
Well, you could, but I think because I'm not on Windows, I'm on WSL, this seems to understand where that .git ignore global is. Let's just make sure that that .git ignore global looks right. It does have node modules in there. Let's just add a space maybe. So once again, I wonder if I have to do this every time I make a change to it. I doubt it, but let me go back to that another repo I made. And first, because I had that issue, if I say git status, it should tell me how to get rid of, if I do git remove -- cache, that should unstage things. So I want to unstage all node modules. Oh, and it won't do that because I didn't add a -r. Okay. And now if I say git status, now it seems to be working. Yeah. So I wonder what made the difference, but now it seems to be saying, like, if I say git add dot, it doesn't seem to want to add node modules because it knows that that's globally ignored, even if there isn't a local one. So yeah, stuff like that is usually possible. It's just a matter of how you want to do it. That's part of the reason why like a boot camp is a great way to learn programming, is that if you try and learn this stuff on your own, there's a billion ways to do everything. And it's very hard to know like what the standard path is. So even though there is all this stuff, hopefully we're guiding you more or less in a, the standard path. Because I've never used that global git ignore. I generally just add a git ignore to each file or each, repo. But yeah, we still have like 8 minutes left. So anything else we want to discuss? There's these assignments for today, so you'll have time to work on these assignments. There's this learn git branching thing, which I've seen a number of these on the internet, but they're basically like, it's like an interactive way to learn Git where you're going to see like a pretty nice visual thing. I never want to read anything, but they're saying like, oh, you make a commit and yeah. Okay. And then like you're able to type something here. So I'm not even sure what it actually expects, but it has, they're saying this is the goal. I'm at C1. So I guess I just have to write git commit and it makes another commit, but just seeing it visually can help. So this is probably gonna be a useful thing. And, we also have our own, where is it? We have our own assignment we created. Sorry, things keep jumping around. We have our own assignment we created, Git practice, but this learn Git branching thing seems to have a lot of modules in it where we don't expect you to go through all of it, but if you did, you'd have learned a fair amount about Git. So yeah, that's what we have to do today. And also InstallFest is still very much a priority. So, none of this really matters until you have a system that is working as expected. So please reach out to us directly to instructors, directly to TAs. We want to make sure your environment is set up as soon as it can be. Let me stop sharing now. And let me stop the recording.